Good day to all participants joining this session. This recording focuses on critical chain project management, CCPM, a methodology for improving flow and reliability. We will cover its core principles, advantages over traditional methods, and industry suitability. Please sit back and let's dive into the material. Critical chain project management, CCPM, is a project management methodology developed by Dr. Eliyahu M. Goldratt, creator of the theory of constraints, TOC, and detailed in his book, Critical Chain, 1997. CCPM is specifically designed to address the inherent inefficiencies, delays, and stress introduced by traditional scheduling methods like critical path method, CPM, and the pitfalls often encountered in pure agile environments. The failure of traditional methods. The failure of traditional methods, the pain points of traditional project management. To understand the value of CCPM, we must first recognize the failures common in traditional approaches, like CPM, PERT, and even traditional waterfall implementations, the tendency for tasks to be started just before the deadline. Even if a task has a long lead time, the team waits until the last minute to begin execution. The student syndrome leads to high risk of last-minute rushes and missed deadlines. Individual task performers add personal safety buffers, estimates, to their task durations to account for uncertainty, fear of failure, or resource contention. Leads to Parkinson's law, work expands to fill the time allotted for its completion. The project duration inflates unnecessarily. Traditional methods often treat resources as infinitely available or fail to properly sequence based on true resource availability. When a key resource works on multiple parallel tasks, they constantly switch context. Context switching destroys efficiency, increases errors, and obscures the true critical path, we called as the critical chain. The teams focus on hitting their individual task deadlines, even if those deadlines are not essential to the project's overall success, leading to wasted time on non-critical activities. What is critical chain project management, CCPM? CCPM is an application of the theory of constraints, TOC, to project management. It focuses on managing the project buffer and resource dependencies rather than just task durations. The core CCPM philosophy, CCPM, argues that uncertainty, variability, in projects should be managed centrally, not distributed across every single task estimate. Critical chain identification. The critical chain is the longest path of dependent tasks in the project network, considering both task dependencies and resource dependencies. If a resource is required for two separate paths, those paths merge into one resource-constrained chain. Aggressive estimating means removing individual buffers. Team members are asked to provide aggressive estimates, durations that they are highly confident they can meet, often around the 50% probability mark, removing most of the individual safety buffer. Centralized buffering. The safety buffers removed from individual tasks are pulled together and placed strategically at critical points in the project schedule. Project buffer, placed at the very end of the critical chain to protect the final project completion date from delays occurring anywhere along that chain. Feeding buffers, placed where a feeding chain, a non-critical path that feeds into the critical chain, joins the critical chain. This buffer protects the critical chain from delays on the feeder path. Focus on throughput. The goal shifts from managing individual task deadlines to managing the consumption of the centralized buffers. Buffers are a tangible metric. Project health is determined by how much buffer time has been used versus how much work remains. For example, we have used 45% of the project buffer, but only 20% of the project work is done. We are behind schedule. By removing task padding and creating a firm deadline, protected by the buffer, the pressure to delay work is reduced. Prioritizes tasks based on resource contention and the longest sequence, ensuring bottleneck resources are never starved or idled. Status is measured by buffer penetration, forcing immediate corrective action when buffers start to deplete early. The fever chart determines when management intervention is required based on penetration depth. CCPM forces accurate identification of resource constraints, leading to better planning for critical personnel. Also provides a robust defense against common variability, leading to significantly higher on-time delivery rates. By aggregating safety time, CCPM typically reduces overall project timelines by 20% to 50% compared to traditional estimates, as the inflated individual task padding is removed. CCPM is most effective in complex environments where resource contention and schedule uncertainty are the primary drivers of project failure. Engineering and construction, where complex sequences of specialized labor and equipment must be managed, e.g., scheduling specialized welders or unique machinery. Product development and R&D, where scientific or technical uncertainty makes reliable individual estimates difficult. Complex software development, especially large-scale enterprise systems, where integration points are numerous and resource contention between different functional teams, e.g., back-end versus front-end, security review versus coding, is common. Manufacturing, especially flow shop or job shop environments where machine downtime or specialized operator availability dictates the pace. CCPM's primary advantage lies in how it handles uncertainty and focus. Handling uncertainty, the traditional project management, uncertainty is distributed across every task estimate, padding, while the CCPM uncertainty is aggregated and managed centrally as buffers. Focus of execution, the traditional project management focus on meeting individual task deadlines, while the CCPM focus on finishing the task quickly and monitoring buffer consumption. Resource management, the traditional project management often ignores resource contention until too late, or focuses on keeping resources busy 100% of the time. While the CCPM identifies the critical chain and dedicates execution focus there, preventing multitasking on that chain. Schedule dynamics, the traditional project management schedule slippage on one task immediately pushes out subsequent milestones, while the CCPM the project buffer absorbs most internal task variations, stabilizing the final delivery date. In essence, CCPM shifts project management from a system that rewards padding and punishes early completion, to a system that rewards speed and manages collective risk through transparent buffer monitoring. Stop padding, start pooling. CCPM focuses execution on the critical chain and manages risk proactively via buffers. Thank you.